Hi there. The mole is a central concept in chemistry. It's the measure of the amount of a substance, but it's not the only way of describing how much of a substance you've got. You can also talk about the number of grams of a substance, or you can talk about the volume in milliliters or liters. If you're dealing with a substance that's dissolved in a solvent like water, you can describe how much you've got in terms of the number of liters of a solution. And you can also think about how much of a substance there is um, in terms of the number of atoms that are in the sample. And all of these ways of thinking about the size of a sample are all connected, of course. And we've seen that if we know the molar mass of a substance, that bridges between the number of moles and the number of grams. Likewise, if we know the density of a substance, that bridges the gap between the number of grams and the number of milliliters. And for a solution, if we know the molarity, that allows us to connect the number of moles of a substance with the number of liters of a solution. And finally, Avogadro's number gives us a connection between the number of moles of a substance and the number of atoms. Today, what we're going to look at is the situation where we want to compare one substance with another substance. So say we have two substances A and B, and the amounts of those substances are related in some way. And so we're interested in the connection between the number of moles of A and the number of moles of B. This relationship between the amount of one substance and the amount of another substance is called stoichiometry. And one of the big places where you encounter this is in chemical reactions. For instance, hydrogen peroxide, H2O2, can decompose into water and oxygen gas. And the chemical equation tells us that the relative amounts of the substances involved in this reaction are 2 to 2 to 1. And so in this reaction, 2 moles of hydrogen peroxide will produce 2 moles of water. It's also true that in this reaction, 2 moles of hydrogen peroxide will produce 1 mole of oxygen gas. And in this reaction, for every 2 moles of water that are produced, 1 mole of oxygen gas is produced. And so you have these stoichiometric relationships between the substances in a chemical reaction. And one place where you can use this idea is, let's say, for example, that we knew that we had 0.28 moles of hydrogen peroxide gas, and we wanted to know how much oxygen would be produced when that hydrogen peroxide decomposes. So the way that we could work this out is we've got 0.28 moles of hydrogen peroxide, and then the stoichiometry of the reaction tells us that there's 1 mole of oxygen produced for every 2 moles of hydrogen peroxide. We can turn that into a conversion factor, 1 mole of O2 per 2 moles of H2O2. And then if we multiply these, then the moles of H2O2 cancel out. And then putting the numbers into the calculator tells us that the number of moles that we get is 0.14. This is a typical example of using reaction stoichiometry to do a calculation for a chemical reaction. Now, very often, stoichiometry will just be a part of a calculation. And so a more complicated example involving the same reaction would be how many grams of oxygen are released when 100 grams of hydrogen peroxide decomposes. So we've got our chemical equation, and the chemical equation gives us the relationship between amounts. And so it gives us a relationship between the number of moles of hydrogen peroxide and the number of moles of oxygen. And specifically, for this particular reaction, 2 moles of hydrogen peroxide forms 1 mole of oxygen gas. Now the question is asking about the number of grams of the substances. And so before we can use this stoichiometric relationship, we need to convert the 100 grams of hydrogen peroxide into the number of moles. We do this using the molar mass of hydrogen peroxide. So hydrogen peroxide has a formula H2O2, and so its molar mass is going to be twice the molar mass of hydrogen plus twice the molar mass of oxygen, and that adds up to 34.014 grams per mole. And so that tells us that 1 mole of hydrogen peroxide has a mass of 34.014 grams. So that makes the connection there. And then finally, once we know the amount of oxygen, we're going to want to convert that into grams. And we can do that using the molar mass of oxygen. Oxygen has the formula O2. Its molar mass is going to be twice the molar mass of the oxygen atom, 15.999 grams per mole. And so that works out to be 31.998 grams per mole for diatomic oxygen. And so 1 mole of O2 has a mass of 31.998 grams. So now we have relationships between all of these quantities, and we can work out the answer to this question. So 100 grams of hydrogen peroxide, we can convert that into moles of hydrogen peroxide using the molar mass, so multiply by mole of H2O2 per 34.014 grams. Grams of H2O2 are going to cancel out, and now we can convert from moles of hydrogen peroxide to moles of oxygen using the stoichiometric factor, that there's 1 mole of oxygen per 2 moles of hydrogen peroxide. And when we include this, moles of H2O2 will cancel. And then finally, to get from moles of oxygen to grams of oxygen, we use the molar mass, 31.998 grams of O2 per mole of O2. So now moles of O2 cancel out, and now we're all set. We can type these numbers into a calculator and determine that from the 100 grams of H2O2, we could make 47.0365 grams of diatomic oxygen gas. And then to get our final answer, we would want to round off to an appropriate precision. And so that would be 47 grams of oxygen. Actually, that would be 47.0 grams of oxygen, because we've got 3 significant figures in the mass of the H2O2. And that concludes this video.